Good morning, good afternoon, good evening. Hope you are all well. So today we are going to discuss 13th problem in the TLA Eliminators CP sheet, 800 rated problems. The problem name is United We Stand. So let's get started. Let's first read the problem statement. Given an array A of length n containing integers, there are initially two empty arrays B and C. You need to add each element of the array A to exactly one of these arrays in order to satisfy the following conditions. So let's read the conditions. Both the array B and C are non-empty. More formally, let LB be the length of array B and LC be the length of array C. Then both of them should be greater than or equal to 1. For any two indices I, j, I is the index in array B and j is the index in array C. C of j is not a divisor of B of I. That means any element in the array C should not be a divisor of any element in array B. Okay, any element in array C should not be able to divide any element in array B. Output the array B and C that can be obtained, or output -1 if they do not exist. So we need to output -1 if the solution does not exist. Otherwise, we need to output the length of the both arrays and then the arrays themselves. If there are multiple solutions, output any of them. You can output the elements of the array in any order. So let's see what they want to say. We'll be given an array A. There will be some n elements and we need to divide those elements into two arrays, B and C, and let's say any combination would work. Okay, so the brute force would be checking all the combinations. Check all the combinations. That is a really bad approach, because even if the constraints are low, I don't think so it will be a great thing. So we are given one condition that C of j should not be a divisor of B of I. So let's see what does a divisor mean. Like 4 can have divisors 1, 2 and 4. 6 can have the divisors 1, 2, 3 and 6. One thing that we can look here is that all the divisors are always less than or equal to the number. So we are going to use this fact in order to get to our answer. So what we are going to do is we'll push the smallest element in the B array and all the other elements will go into the C array. Now this condition is always going to be true because a bigger element can never divide a small element. Like 7 cannot be a divisor for 4. That's why this condition will always hold. Now let's see the sample test cases. Suppose we are given 2, 2 and 2. So all of them would go to the array A itself because they are all the same. To the array B. So 2, 2, 2 and the array C would be empty. So we cannot have the answer here. So it will be -1. Then we can have 1, 2, 3, 4 and 5. So we can have B, that is 1, and in the C we can push all the other elements. Similarly for the third test case, 1, 3 and 5. We can have 1 in C and 3 and 5. We can have 1 in B and 3 and 5 in the C array. Similarly for these and this. Now in the fourth test case, we need to sort them first because 1 and 1 can come twice and any number of times. So we will first sort the array in order to get the smallest element and the frequency, and we will then push them. So let's write a bit of code. We will take the array input, that is n. Then we will take the array ARR of n. After that we will sort the array. After sorting, we will push all the instances of the smallest element into the array B and all other elements into C, and we will just check in the end. If B and C are not empty, not 0, then we will print them. Otherwise we will print -1. That's all we need to do here. Now let's get to the coding part. Now let's code it up. I have my boilerplate code here. We will be given an n, that is the number of elements in the first array. We will define the array and we will take the array as input. Then we will sort the array. After that we will create the array B and C. Now we will iterate. We'll have an index variable for iterating through the array while index is less than n, and an ARR of index is double equal to ARR of 0. Till the element at the index is equal to the first element, we will push it into the B array, and we will increment the index. Now we will push all the other elements into the C array. Now while index is less than n, C dot push back ARR of index, and we will increment the index. Now we will have the check conditions. If b dot size double equal to 0 or c dot size double equal to 0, then we will print -1. Otherwise we will print first the sizes, then the elements. Auto I n b, say out I, new line. Similarly for the C array, so I in C, C out I, and a new line. Now this condition is not required since we are always going to push some elements into the B array. Initially the index is 0, so we are always going to push one element. So that's why we can get rid of this condition. And yeah, so this is going to be our code. Let's try it for the sample test cases. -1, 1, 4, 1, 2, 2, 5, 3, and yeah. So this code is going to work. So the code works for the sample test cases. Now let's try to submit it. Paste and submit. It's in the queue and it got accepted. That means our solution is correct. I hope you got the approach. If you have any doubts, do comment down in the comment sections. This is a series for all the problems in the CP sheet. Do check out all the problems as well. Like the video, subscribe to the channel and share it with your friends. Also comment down what was your approach for solving the same problem. Thank you.